Rectilinear motion is defined as a particle's motion along a straight line. Here are some terms that we need to know when studying rectilinear motion. The first one is the distance. It is the measure of how much ground an object has covered during its motion. The next one is the displacement. It is the measure of how far out of place is an object. We also have velocity. It is the rate of change of its position with respect to a frame of reference and is a function of time. The next one is acceleration. It is the rate at which velocity changes with time in terms of both speed and direction. And lastly, we have the speed. It is the rate of change of position of an object in any direction. The following are the formulas used in rectilinear motion. The first one is d is equal to VIT plus 1/2 AT squared. The next one is V is equal to D over T. The third one is VF is equal to VI plus AT. And lastly, VF squared is equal to VI squared plus 2AD. Where A is the acceleration, VF is the final velocity, VI is the initial velocity, T is time, and D is distance.
For our first problem, a truck traveled from Manila to Laguna with a velocity of 45 km per hour. It traveled from 7:30 a.m. and comes to rest at 8:15 a.m. upon reaching its destination. Determine the distance covered by the truck. Writing our given values, we have a given velocity of 45 km per hour and the time of 45 minutes since the truck traveled from 7:30 a.m. to 8:15 a.m. Since we're getting kilometer per hour, we should convert our time from minutes to hour. So 45 minutes, converting it into hour. Cancel both minutes. By using your calculator, you'll get 3/4 R, which is equivalent to 0.75 R. In this problem, we are trying to determine the distance which was covered by the truck. And to get the distance, we're going to use the equation velocity is equals to distance over time. And from this equation, we can have the formula d is equals to v times t. D is for the distance, V for velocity, and T is for time. After this, we can now substitute our given values in the formula. So for the velocity, 45 kilometers per hour times 0.75 R. Cancel both R's and then you'll get 33.75 kilometers. Therefore, the total distance covered by the truck in 45 minutes or 0.75 R is 33.75 kilometers.
Angela rode the bike from their home to park, which has a distance of 41.3 meters. Upon driving, her bike accelerates uniformly from rest to a speed of 6.9 meters per second. Determine the acceleration of Angela's bike. For us to solve this problem, we should identify the given first. We have a given distance of 41.3 meters. Her bike accelerates uniformly from rest, which means it has an initial velocity of 0 and a final velocity of 6.9 meters per second. After we identify the given, we should know what is the required in the problem, and that is to determine the acceleration of Angela's bike. Based on the given, we will have an equation of Vf squared is equal to Vi squared plus 2AD. After this, we will substitute the given values on the equation. We have 6.9 meter per second squared is equal to 0 squared plus 2 multiplied by the acceleration and the distance, which is 41.3 meters. We will just cancel 0, so we have now 47.61 meters squared per second squared is equal to 82.6 meters multiplied by the acceleration. For us to solve the acceleration of it, we will just divide 47.61 meters squared per second squared by 82.6 meters. We will just cancel the meter, and the acceleration of Angela's bike is 0.51 meter per second squared. And this would be our final answer.
For our third problem, a rocket-powered sled is accelerated to a speed of 554 meters per second in 2.73 seconds. Determine the acceleration and the distance that the sled travels. Before solving the problem, you should know first what are rocket-powered sleds. These are sleds that are used to test the human response to acceleration. For this problem, we're going to start by identifying our given values. So it was said that the sled or the rocket-powered sled is accelerated to a speed of 554 meters per second, which means that our initial speed is 0. We also have a given time of 2.73 seconds. And with these given values, we are required to determine the acceleration and the distance that the sled travels. Since we already have a given speed and time, we can use the formula A is equals to delta V over delta T, which is final velocity minus the initial velocity divided by time. With this equation, we just have to input our given values in the formula. So we have a final speed of 554 meters per second minus the initial speed of 0 divided by 2.73 seconds. And by using a calculator, we will get an acceleration of 202.93 meters per second squared. After getting the acceleration, we can now get the distance. For the distance, we can use the equation d is equals to VIT plus 1/2 AT squared. We can cancel this out since this is just going to be 0. And we will be left out with 1/2 AT squared. And by substituting the values, 1/2 multiplied by the acceleration, 202.93 meters per second squared multiplied by the time, which is 2.73 seconds squared. Cancel both seconds squared. By using our calculator, we will get a distance of 756.21 meters. Other than that, you can also actually get the distance in this problem by using the equation Vf squared is equals to Vi squared plus 2AD, since we have the given values for the formula. So substituting 554 meter per second squared is equals to 0 squared plus 2 multiplied by the acceleration 202.93 meter per second squared multiplied by d. So d will be equal to 554 meter per second squared divided by 2 multiplied by 202.93 meter per second squared. By using your own calculator, you will also get a distance of 756.21 meters. Therefore, the rocket-powered sled has an acceleration of 202.93 meters per second squared and traveled a distance of 756.21 meters.
Angelo threw a stone vertically upward. After 12 seconds, it reached the ground. Letter A. Determine the initial velocity. Letter B. How high did the stone go? We will solve first the initial velocity, and for us to determine it, we will first identify its given. Its direction is upward. The velocity at the highest point is 0 because it will stop before it will fall on the ground. It also says here that it reached the ground after 12 seconds. So, reach in 12 seconds is equal to 6 seconds upward plus 6 seconds downward. So therefore, our given the final velocity is equal to 0, time is equal to 6 seconds, and the gravity is equal to 9.81 meter per second. We will use the equation Vf is equal to Vi minus Gt. So using this equation, we will only substitute our given values. Using Vf is equal to Vi minus Gt. Vf is equal to 0 equals initial velocity minus the gravity 9.81 meter per second multiply by the time, which is 6 seconds. Therefore, our initial velocity is equal to 58.86 meter per second. And that's the final answer. We will now solve how high did the stone go. Since its direction is going downward, it has an initial velocity of 0 because it is free fall. And for us to determine it, we will use the formula d is equal to 1/2 gt squared. We all know that gravity is equal to 9.81 meter per second. And as we have solved on the previous question, our time is equal to 6 seconds. So what we have to do now is to just substitute the given on the formula. So d is equal to 1/2 times the gravity, which is 9.81 meter per second, multiply by the time, which is 6 seconds, squared. Therefore, our d is equal to 176.58 meters. And this would be our final answer.